Here are some grade A stroke A star simultaneous equations where one of them is linear as normal and the other one is in fact quadratic. What happens is you generate a set of answers for the x's, 2 answers, and therefore 2 answers for the y as well, or whatever letter they choose to use. Now question 2a is the first of its kind. If you take a look very carefully, we've got y equals 7x plus 2, very easy, but here I've got y equals 4x squared. This is linear, as you can see, it's based on y equals mx plus c, and this is quadratic. And the only way to merge these two, we can't double the top or the bottom, we can't eliminate the x's, but we can substitute the 4x squared where the y is in the upper equation. So we're going to get this: 4x squared equals 7x plus 2. Get the idea? Bring it all over to the left hand side. Equals 0. Solve it like an ordinary quadratic, because that's what it is. Again, it's hard to know whether we're going to go for 4s or 2s. I don't know yet. Let's go for 2s. How do we make 2? That's going to be 2 times 1. Will that work? That's going to be 4 plus 2. That's not going to work, is it? Because 4 plus 2 will only give me 6 x's, not 7 x's. So, you know, I tried it, so I've decided it doesn't work. I'm now going to go for 4x and x. Yes, 4 times 2 will make 8, 1 times x will make 1, and I can subtract to get 7 x's quite easily. Right, I want minus 8x plus 1x will give me minus 7 x's, and 1 times minus 2 is going to be minus 2. So I'm happy that I've factorized it correctly. Therefore x is going to be minus 1/4. Again, this is, you know, higher level now. You should know what I'm doing here. And x is going to be 2. These are the two solutions. Therefore, I've got to substitute back into here to find the equivalent y values. So if I work like this, then, you know, this value here for x is going to be the one I'm going to use to find its corresponding y value. So here we go. Y equals 7 lots of minus 1/4 plus 2. Well, 7/4, well, 7 times 1 is going to be 7, so that's going to give me minus 1 3/4 plus 2. That's going to be minus 1 3/4 plus 2, puts me on a positive quarter. So y equals minus 1 3/4 plus 2. Y is going to be a positive quarter. And that side's done. Substituting x value for 2 in the top equation, I have y equals 7 lots of 2 plus 2, and that's dead easy. 14 plus 2, 16. Much easier. So there we go. Like I said, we've got 4 values, 2 x values, and their corresponding y values. Let's get rid of that black bit there. Okay, that's that one. Let's put a nice line down the middle, cut Helen in half. Sure she won't mind. Let's do C now. Question 2e, I'm going to go for it. I've got y equals 2x plus 11. I've got y equals 2x squared minus 7x plus 6. Again, merging the two, I've got 2x squared minus 7x plus 6 makes the equivalence of 2x plus 11, because y equals y, so their equations on the right hand side are also equal. Bring it all to the left hand side. 2x squared minus 7x plus 6 minus the 2x minus the 11 is 0. Simplifying on the left hand side, 2x squared minus 7 minus 2 minus 9x. 6 minus 11 is minus 5. That equals 0. Looks pretty easy now. 2x and x, how do you make 5? 5 times 1. I want to get negative 10x's plus the 1x will give me minus 9, and 1 times minus 5 is minus 5. So I've got an answer of minus half there for the x, and x is going to be 5 on this side. So here's my first set of values. Again, split it down the middle, see what's going on. Substitute the minus half in there. So I've got the corresponding y value is going to be 2 lots of minus a half plus 11. So that's going to be minus 1 plus 11, 10. And I'm happy with that one. Here I've got y is going to be 2 lots of 5 plus 11, so we've got 10 plus 11, 21. So y is 21, and I'm happy with you as well. Check it, 10 plus, yes, that's good. Let's do some more, because these are quite tricky. The mouse, I've got no space for the mouse, let's just use the pen. Right, here we go. Okay, I want to try and do F now, which is question 2F. It looks really tricky. Let's go for it. I've got x minus y is 1. I've got y is 5x squared plus 7x minus 9. Rearranging this, I get y equals x minus 1. Just brought the 1 over and subtracted, and the minus y over and added. So y equals x minus 1. I'm just going to substitute, obviously, that little part into here and just carry on with the maths. So x minus 1 equals 5x squared plus 7x minus 9. Bring it all over to the right hand side. Nothing equals 5x squared, 7x minus 9 minus the x and plus the 1. Squishing it up a little bit. 5x squared, 7x minus 1x is going to be plus 6x. Minus 9 plus 1 is going to be minus 8. Well, that's going to come to 0 because we've got a quadratic. We factorise away in the normal way. So I've got 5x and x. How do you make 8? Has to be 4 and 2. So if I put 4 there, I end up with 20x is too big. So 2 and 4 should be better. Let's just take a look at that. Yeah, I'm going to go for plus 2 to make 10x's, minus 4 to make minus 4x's. 10x minus 4x, of course, is 6x. So I'm happy that's correct. Of course, minus 4 times 2 is minus 8 anyway. Let's just solve this part. X equals 4/5, and here x equals minus 2. Again, let's work out the corresponding y values. Put 4/5 into there. I've got 4/5 minus, in fact, let's shove it into this part here. I mean, why rearrange it and get all complicated? I know y equals, let's just go. Y equals 4/5 take away 1. That would give me minus 1/5 underground, or below 0. That's that one done. And substitute minus 2 into there. I've got y equals minus 2 minus 1. So that's going to be equal to minus 3. And these are my values. So when x is 4/5, y is minus 1/5. When x is minus 2, y is going to be minus 3. And could do h, I suppose. That will require a separate page because these things can get quite involved. Let's just do h, and it's the last one. Back to black. Right. X plus 2y comes to 2. I've got y equals x squared minus 6x plus 7. Well, I could double this up, I suppose, and shove it in there. Is there a better way? No, it looks quite simple. If I double this up, here I go, times 2, I'm going to have 2y equals 2x squared minus 12x plus 14, and stick the x onto the end of that one, and that equals 2 apparently. Let me just check. Yes, it does. So here I go. I've got x plus 2x squared minus, I just worked it out, minus 12x plus 14. Okay, so that's all that, and that equals 2. Tidy it up a little bit. 2x squared minus 11x plus 14, take away the 2 is 0. Tidy it up further. What we got here? Minus 11x, that's going to be plus 12 equals 0. And now we factorise away and try and land the x's. So we've got 2x and x. Yeah, how do you make 12? 6 and 2. That's not going to work, is it? 12 take away 2 is not going to be 11. So either I've made a mistake or I've got to think of some other way of doing it. 4 and 3 perhaps? 4 and 3 perhaps? Yep, that's the one. 4 and 3. 2 times 4 is 8. 3 times 1 is 3. 8 and 3 is 11. Very happy. Both got to be negative to make minus 11 x's. Minus 3 times minus 4 is plus 12. So I knew you got caught out, but that's what happens in exams. You have to try it, think again, review it, change it. So substituting, working this side out, I've got x equals 3 over 2, or in other words 1 and a half. This side I've got x is 4. Right, let's work out the y by shoving it in this little bit here. Looks quite easy. So let's work out the corresponding y values. I've got 1 and a half plus 2y equals 2. So 2y is going to be 2 take away 1 and a half, and of course 2 take away 1 and a half leaves me with a half. So 2y is a half, and so y must be half of a half, a quarter. Substituting x equals 4 up there, I've got 4 plus 2y equals 2. Subtract the 4, 2y equals minus 2. Y is going to be minus 1. And these are my lovely values. When x equals 4, y is minus 1. When x equals 1.5, y equals a quarter. I'm going to stop there. Let's just call it x and y, okay? Good old Mel. Their difference is 3. Oh, so x minus y equals 3. I don't care if it's y minus x. I don't care at the moment, but I've just obeyed what the story says. The sum of their squares is 89. In other words, that squared plus y squared is 89. What are the numbers? Well, let's get rid of one of these little things here. If I say x equals 3 plus y, I can substitute this 3 plus y where the x is and see what happens. I end up with an equation with just y's in it. That means it's solvable. So here we go. I've got 3 plus y all squared plus y squared comes to 89. Do this, I'm going to end up with, let's have a look, 9 plus 6y plus y squared plus y squared is 89. Check it. 3 3's are 9, 3 y's, 3 y's, 6 y's, y squared. Okay, let's tie these up a little bit. I've got 2 y squareds plus a 6y. Now bringing the 89 over and subtracting, I go minus 80 equals 0. Okay, 9 take away 89 is minus 80. Divide everything through by 2 because it can be done. 9 anyway, y squared plus 3y minus 40 equals 0. It looks like a straightforward grade B equation now, doesn't it? That worries me. So y and y, how do you make 40? 5 eighths of 40, and 5 and 8 will give me a 3. Look at that. So I want minus 5 plus 8 will give me 3 y's, and 8 times minus 5 of course is minus 40. So I've got y equals minus 8 for you and y equals 5 for you. Now I've got to work out the corresponding x values, so I'm going to work up here now, and I fancy red. Now put it into this equation here. I've got x equals 3 plus negative 8, in other words 3 minus 8, in other words minus 5. You're sorted. And for you, sir, I've got x equals 3 plus 5 and x is 8